measure. Let's make sure in label top right hand corner. 8, 20, 13. Top 1.2. What do you think linear deals with? You should know.
Lines.
Lines, very good. If you look on the pages, we're dealing with measuring something with a ruler and things like that. That's not too bad, huh?
It could be.
There are some things first we need to talk about. Before we talk about linear measure, we talk about lines and stuff. A thing that we will use constantly in this class, more than lines actually, is a line segment. Segment of a line with two distinct endpoints. Picture of one, have a dot here and a dot here. Let's call this A, let's call this B. What do you think when I connect the dots, guess what I have? I have a line segment. I didn't connect the dots very well there. A and B are a part of a line, are they not? So if I wanted to just talk about from here to here, I would talk about AB, segment AB, but I can't leave it blank. I have to put a segment up above it. If you notice, what's not on the end of that segment?
Arrows.
Arrows. That means segment from A to B. Okay? I could have other points up here. I could have a C up here. I could have a D. I could have an E. Are there a lot of different segments I could write there?
Yes.
Yes. Is segment AB the same, in essence, the same segment as segment BA?
Yes.
Yes, it is. Because direction isn't really that important. It's still talking about the same piece of that line. Okay? However, and this is very, very important, and this is why it's so important to speak the language and know what you're saying. Does anybody know what that means?
Points, AB.
Not yet.
I haven't got anything written above it, do I?
No.
No.
This was, with the segment up above it, was segment A,
B.
B, right?
Uh-huh.
On this, did I write anything up above it?
No.
No.
So it's point.
Believe it or not, what this means,
Same thing.
Same thing.
this represents a number. This is the distance from A to B. Represents the distance from A to B. So wow, that's a big difference, isn't it? Here I'm talking about the segment from A to B. I'm talking about the actual segment. When I just write AB, I'm talking about an actual number. That's the distance from A to B. If I wrote CD and put a segment above it, I'm talking about a segment. Correct?
Correct.
I take CD without anything above it, I'm talking about distance from C to D. This is a picture. This is a what? A number. Right? Centimeters, inches, so on and so on. You say, why'd they make it confusing? Well, like I said, mathematicians are lazy. They don't want to write, hey, what is the distance from C to D? They just ask you find what? CD without anything above it, and they're asking you to what? Find the distance from C to D. It's your job to know the difference. Okay? Make sense? Very important thing. It's not good enough to write CD without a segment above it if they were asking. If I ask you, give me an example of a segment that has A. In fact, I'll write this question. Let's do this question. Give me an example of a segment that has the point A in between its endpoints.
Are you talking about the lines you just drew?
Yes. I'm referring to this picture up here. Give me an example of a segment that has the point A in between its endpoints. In essence, that has A in between, or has A inside of it. Excuse me?
EC.
Say EC?
So, yes.
Is that the correct answer?
With the segment
You have to
of
have a segment line.
Right. That's not, and that's the point I'm making. That's not a correct answer. That's a number. Okay? That's the distance from E to C. They're asking for a segment. So you have to, it's not, even though the E and C, really the hard part you got right, don't get lazy on me. You need to denote that you're talking about the segment E to C. Or, can anybody give me another answer?
CE.
Huh?
CE.
CE would work. Any others?
B for
AB.
segment.
I mean EB.
EB would work. Segment EB. So when you say that to me, you shouldn't say EB. You say EB to me, I think you're talking about what?
The
The
number.
number.
The distance. You should say segment EB. What would be another possible answer?
Segment ED.
Segment ED. Okay. AB would not be correct because A is an endpoint. So A couldn't be in between it, could it? Next thing we need to talk about is the betweenness of points. Or this may, you'll see a lot of these, if M is between points P and Q, then PM plus MQ is equal to PQ. And I want to see if any of you can draw that for me. Draw an example of that. And then after you're done, I'll try to do the I'll draw how I would draw it. Think about that situation I've demonstrated up there. Draw and label the picture. You can always scribble it out after I draw the correct picture. Think about what it's saying to you and draw the picture. This is what I see. I'm going to draw it up here, but I'm not unfreeze it yet. you guys get? Did you get something like this?
Yeah.
Okay. Magic. Poof. Just snap my fingers, it was drawn. Now, you see how M is between. Now, what this is saying, and think about it, isn't this just common sense? If I said from here to here was 5, and then the distance from here to here was 10, what would the whole distance be?
15.
It's amazing how we have problems with that sometimes. Doesn't the two smaller parts always equal the whole? Wouldn't you agree with that? That's the definition of betweenness. Okay? I have one more thing I want you to write down. This is a side note, and we'll write it right here, I guess. In geometry, when a problem looks like an algebra problem, first of all, what do you think I mean by that? What's the first thing you think of when you think of algebra?
Letters.
Letters, right? 3x, 3x plus 4, something like that. So that's what I mean when it looks like an algebra problem. In geometry, when a problem looks like an algebra problem, 99.9% of the time, the problem wants you to use the info given to create a valid. What is the number one thing you deal with in algebra?
Numbers.
Or letters and then
Expression.
equation. 3x plus 4 equals 10, right? Something like that. Don't you deal with equations all the time in algebra? Yeah. Equations have equal signs. My point in writing that down is that, you know, when you're doing, now that I've got this up here, but I fold it like this, and maybe I can make it where you guys can see a little better. You know, from now on, you'd be amazed at how much you're going to use algebra. The one problems everybody wants to skip are the ones that say, like for instance, the problem I just gave you, there was no problem saying that that whole length was 15. When one was 5 and one was 10, right? You would probably have no problem if I said, hey, the whole thing's 15 and the piece of it's 10, what's left? 5. Isn't that x plus 10 equals 15? They're going to give you problems that deal with geometry concepts, you know, the theorems and postulates you've learned, which are basically definitions you've learned in that section. They're going to ask you to apply that knowledge with the information given, and most of the time it's going to end up being an algebra equation after that. So it's algebra the rest of the way to find the answer. Okay? When I say valid equation, you just can't make any old equation. Oh, I made an equation. Well, that doesn't mean it's the right one. Okay? And one thing about equations, remember, what do equations do? What's the main thing what makes something an equation?
Equal sign.
The equal sign. So you need to find quantities that are equal. Okay? With that in mind, let's get out our little red books. We'll go to an example. These are still part of the notes. It's just we can do more problems because they're already written down. because we're on this, I want to skip all the way to number 5 on page 4. I'm going to rewrite what they've given to you up here a little bit because I want to draw a picture. I just like to draw. First they say, find the value of x and RS. So on number 4, well, we're supposed to find what x is equal to, and then find out what RS is equal to. RS means the distance from R to S, does it not?
Yes.
If S is between R and T. So I can draw kind of a general picture up here. S is between. So that's S, correct? This is R, and this is T. So that's for all those problems on 5 through 8. We're dealing with that. Oh, this isn't number 4, this is number 5, isn't it? I apologize, number 5. That's what we're supposed to find. Number 5, they give us that RS is equal to what? 5x. ST is equal to 3x. RT is equal to what? What does this problem look like? Algebra. So what do I probably need to create?
Equation.
Any valid equation. Well, first label your picture. What is RS? 5x. ST? 3x. What's the whole thing?
48.
What did we say we learned today? That the two parts added together equal the what? So this piece plus this piece has to equal the what? The whole thing. Would everyone agree with that? So, how would I make my equation? The two smaller parts added together, what are the two smaller parts?
8x.
No, I don't want them added together. 5x is this part from here to here, right?
Yep. Plus
Added to this part, which is what?
3x.
Would equal the whole thing,
48.
48.
equal the whole thing, which is?
48.
You've created a valid equation, haven't you? At this point, like I said, the rest of it's a what kind of problem?
Algebra.
Algebra.
Combine your like terms, solve for x. 8x is equal to 48.
6.
Divide both sides by 6. X is equal to?
6.
Now, it's important, I'd hate for you to do this on a test and they ask for RS. Yeah, you did most of the work. You've done the hard work now. What did they actually ask for?
RX.
This problem was asked for X and RS. Well, what is RS going to be?
5x.
5 times whatever X is. What did I find X to be?
6.
6.
So it's equal to what?
30.
30.
They didn't give you feet or anything like that, right? No. Let's do number 6. Number 6. RS is equal to 2x, right? ST is equal to 5x plus 4. RT is equal to
32.
32. Same situation. Shouldn't be hard to write the picture down. RS, 2x. ST, 5x plus 4. What's the whole thing?
32.
What's my equation?
5x plus 4.
I add the two smaller parts equal the whole, right? So what are my two smaller parts?
2x.
Plus, what's the other part?
5x plus 4.
Equals, what's the whole thing?
32.
Now it's just an algebra problem, isn't it? 7x plus 4 is equal to 32. Subtract 4, subtract 4, 7x is equal to 28. Divide by 7, x is equal to?
4.
What's the other thing I gotta find?
RS.
s is 2 times whatever x is. X I found to be 4, so what's it?
8.
Easy peasy, huh?
Yep.
I'm gonna do a rest on the actual pieces of paper. How's sound go?
About 25
20
minutes.
minutes.
Okay, I'll do a couple more, then we're done.
Yeah.
We're actually gonna go back up to number 1, 2, 3, and 4. Find the measure of each segment, assume each figure is not drawn to scale. That's another thing in geometry, very important. A lot of times they will draw the stuff to scale. But just because, for instance, if 2 things look like they're the same length, does that mean they are?
Oh.
No. However, if you're on your last, you can't remember anything about the problem, you're on a problem that you can't figure out how to do, and they have a picture drawn, as a last resort, can you maybe, multiple choice math, can you maybe go by the picture to help you? You might try that, but you can't count on that. Just because the picture looks like it does not mean it is. Okay? The pictures are just that, something to just kind of help represent what you're talking about. Now, going to these. Number 1, find the measure of each segment. When they say that to me, I think they're wanting to, they gave me this, what do they want me to find?
Whole thing.
The whole thing. Obviously, what is it?
RT.
4.5 what?
5.
Millimeter. Or is it centimeters?
Centimeters.
My
Or
bad.
40
Centimeters.
centimeters.
Now here, they gave it 6 inches. From here to here is 2 3/4.
Total minus.
So they want
So how much is left for here? 3 1/4 inches?
Mhm.
Because then those 2 added together have to be what?
6.
5.
This one right here, you know what I'd do? Hey, you got a calculator that does fractions for you? Guess what I'm going to do here for this one? I know that the whole thing is those 2 added together. 3, ABC 1, ABC 2, plus 3 over 4 equals. What's the answer?
4 1/4. Look cool.
Isn't it nice to have a calculator that does it for you?
Yeah.
Okay, last one, look at number 4. Even though we haven't got into this yet, these marks
Mean equivalent.
mean that they're the same. It means that they're congruent. We'll talk about congruent in the future. We're getting ready to. It's something you'll use all the time. Congruent means same size. Not necessarily the same thing, exactly the same thing, but same size. What they do have is exactly the same measure. So what they're saying is this is the same length as that. How many different ways can you split 6 up evenly? There's only one way to do it, isn't there? 3 and what?
3.
3.
So divide by what?
3.
2, right? You went 6 divided by 2, because there's only one way to split 3 up evenly. Agreed? So the segments they want you to find are WX and XY, and they're both what? 3 centimeters. Make sense?